All right, so in this example, we're asked to graph the function y equals x cubed and its inverse on the same axes. All right, so let's just first of all start with y equals x cubed. Now, I'm just going to make a little table of x and y. That's an easy way to do it. Now, I probably don't need to make a table. I could probably just figure this out in my head, but I want to I want to illustrate a point here, so I'm going to actually make a little table. Okay, I'm just going to just choose some input values kind of randomly, right? And then I'm going to calculate the output value, right? I'm just going to cube these input values. So if I cube -2, I get -8. Cube -1, I get -1. Cube 0, cube 1, cube 2. Okay, so now I have a table of input and output values, and I can just plot those values. So, okay, so I have 0, 0, and I have 1, 1, and I have 2, 8. I'm just going to plot these points, and then I have -1, -1, and -2, -8. Okay, so there's some points. All right, and I'm just going to connect up those points to graph the line. So let's see how well I do with connecting these points with my pen here. All right, so that's kind of getting off there. All right, you get the idea, right? That's essentially what you get the gist of what the what the function looks like, right? That's sort of a graph of the function. All right, now let's graph its inverse. All right, so if we want the inverse of this function, we're just going to swap x and y, right? So so I could write this as x equals y cubed, right? And if I want to solve for y in terms of x, I'm just going to raise these both to the 1/3 power, right? All right, and I get y is equal to basically x to the 1/3. Okay. So let's make a little table of x and y for that. All right, and y. Now I'm not going to choose my x's so randomly this time because, if I, 0 and 1, that's pretty easy to take a cube root of that. But, if I choose cube root of 2, I have to get out my calculator. And I don't feel like getting out my calculator. So I'm actually going to choose the just knowing that this is the inverse of the function, it's actually easier to choose the output, right? So because I can just take the values that I used for the original function x cubed and swap the x and y values. All right, so I can actually take what was the input to x cubed and use it as the don't want that to be a negative. Use it as the output, right? So I'm just going to choose y values first, and then I know that the corresponding x values are the y values I had before, right? -1, 0, 1, 8, right? So you can see, the inverse function just has the x and y values swapped. Now I'm actually going to change colors here because so you can kind of distinguish these two graphs apart. So okay, so really these points remain the same, right? The 0, 0, 1, 1, and -1, -1, those stay the same. But when I put in 8, I get 2, okay, to this inverse function, and when I put in -8, I get -2. Okay. So now let's connect up those points. All right. So here's a graph of the inverse function. Okay. Good enough. All right, there's my inverse function. Okay. And you can see that, again, I just swapped x and y values. So like in my original function, like this was the point 2, 8, right? And the corresponding point in the inverse function is just over here, 8, 2. Okay. So again, my original function had the point -2, -8. So my inverse function has the point -8, -2. Okay, we're just swapping the x and y values. And you can see when you do that, let me see, I got another pen here. it's symmetric, right? It's just the inverse is just a reflection across the y equals x line. So let me see if I can graph. Oops, I'm trying to, yeah. All right, so this is y equals x. Okay, it's just a reflection. All right, so next we're just going to talk about the inverse of an exponential function. And I will meet you for the next example.